Okay, so let's jump right in. The title of this explainer might sound, well, completely backwards, right? The paradox of plenty? How on earth can saving water actually lead to using more of it? It doesn't seem to make any sense. But we're going to unpack this strange reality because it's at the very heart of a silent crisis that's threatening our global food supply. I want you to keep one number in your head as we get started: 40%. Just 40%. On its own, it's just a number, but it's absolutely central to our global food system. And here's what it means: that 40% of the world's food comes from just 20% of the world's farmland, and that 20% is the part that gets irrigated. So think about that. A tiny fraction of the land is doing a massive amount of the work when it comes to feeding all of us. It just shows you how unbelievably important irrigated farming is. And this map shows you where that engine of production is running the hottest. See those deep red and purple areas? That's primarily the Indo-Gangetic Plain in South Asia. These are some of the most intensely farmed, most productive agricultural regions on the entire planet. But, as we're about to see, that incredible productivity comes with a very steep and very hidden cost. So here's our game plan. First, we're going to look at the scale of the problem and why some are calling it a global bankruptcy. Then we'll get right into that paradox, the efficiency trap. After that, we'll look at the economic policies driving all this, then frame the key facts for policymakers, and finally, we'll talk about the crucial questions we still need to answer to find a way out of this. All right, first section, you need to understand this isn't just a simple water shortage. Researchers have started using a much more serious term: hydrological insolvency. It sounds intense, and it is. Let's break down what it really means. The easiest way to think about it is like your bank account. Your income is the water that comes from rain and rivers every year. It's what gets replenished. But when you're hydrologically insolvent, you're spending way more than your income. So you have to start dipping into your savings. In this case, that's the ancient water that's been stored deep underground in aquifers for thousands of years. We are liquidating a one-time inheritance to pay for our current expenses. To put it another way, our yearly water income from rain is renewable. It comes back. But the groundwater we're pumping is like a fossil fuel. It's a finite resource, a nest egg that took millennia to build up. And once we drain that account, it's not coming back in our lifetime, or our grandchildren's lifetime, or in any meaningful human timescale. So you hear all that, and the solution seems pretty obvious, right? If we're running out of water, we just need to be more efficient with it. But what if that simple, common sense idea is actually the thing making the problem worse? Welcome to the efficiency trap. I mean, it just has to be true. It feels like a law of nature. If you use a more efficient machine, you use less of the resource. If a farmer switches to a high-tech irrigation system that uses less water per plant, the farm must be saving water overall. It just has to. And there it is. That's the twist. That common sense assumption is quite often completely wrong. And understanding why is the key to this whole puzzle. This whole counterintuitive idea actually has a name. It's called the Jevons Paradox. It was first noticed way back in the 1800s with coal. When steam engines got way more efficient, England didn't start using less coal. No way. They used a lot more because efficiency made coal power so cheap it opened up whole new industries. It's the same reason that when you buy a more fuel-efficient car, you might be tempted to take more road trips because each mile is cheaper. That's the Jevons Paradox right there. And here's exactly how it plays out in agriculture. A farmer invests in super efficient drip irrigation. Great. Suddenly, the cost to grow each plant goes down. So what does a rational farmer do? Well, maybe now they can afford to plant on that extra field they owned. Or maybe they'll switch from growing something like wheat to a much thirstier but more profitable crop like cotton or almonds. So the efficiency per plant went up, but the total water use for the whole farm went up too. And efficiency isn't a silver bullet. For a crop like rice, which is grown in flooded paddies that naturally keep weeds down, switching to drip irrigation would mean you'd need way more labor or herbicides to control the weeds, which can cancel out the benefits. Now, this paradox doesn't just happen on its own. In places like South Asia, it's being poured gasoline on by government policies that have created a really dangerous feedback loop. So here's how the loop works. To support farmers and keep food affordable, governments provide huge subsidies on electricity for farming. This makes the cost of pumping groundwater practically zero. So what's the incentive? To pump as much as you possibly can. This causes the water table to drop lower and lower. Now farmers need bigger, stronger pumps to reach that deep water, which use even more electricity. So what happens? Often the subsidies are increased to help them cover the new costs. It is a vicious cycle, a depletion death spiral. And the scale here is just It's hard to even wrap your head around. We're talking about a system that has locked in around 260 million farmers, a quarter of a billion people, into growing thirsty crops like rice and wheat, using this unsustainable method. And it all started with the well-intentioned goal of feeding the country. Okay, let's shift gears. Let's pretend for a minute you're a policymaker, maybe a minister of agriculture. You've got 5 minutes to get the core facts. What do you absolutely need to know? Here's the briefing. First things first, the big picture. Where is our freshwater actually going? 70% of it is withdrawn for agriculture. Let that sink in. 70%. That means any serious conversation about fixing our water problems has to start with farming. Everything else is basically a rounding error in comparison. So, the obvious question is, why don't governments just stop the subsidies? Well, because it's an absolute political and social minefield. Trying to take away subsidies from millions of farmers is widely seen as political suicide. Just think about the sheer cost of trying to put a meter on every single one of millions of wells. But even more important, we don't really know what the fallout would be. If water gets more expensive, what happens to the tenant farmers or the landless workers who depend on the farm for their jobs? These are the kinds of tough questions that just paralyze any attempt at reform. And all that uncertainty brings us to our last section. Before we can design policies that actually work and don't just create a whole new set of problems, there are some massive gaps in our knowledge that we desperately need to fill. We have to solve some really big puzzles. For instance, what really happens at a regional scale if everyone adopts drip irrigation? Does water use actually go down? What about solar pumps? When the energy to pump becomes literally free from the sun, does that just throw the Jevons Paradox into overdrive? Then there's wastewater. It's a potential resource, but what are the long-term effects on soil? And maybe most importantly, we have to understand the human side. If we change the price of water or energy, who wins and who loses? How do we protect the most vulnerable people in this system? And this chart right here is the reason this is all so urgent. This shows the places on Earth that are draining their groundwater the fastest. Look at that first bar all the way on the left, the Northwest Indian subcontinent. It is so far ahead of everywhere else, it's literally off the charts. This is not some distant future problem. It is a full-blown crisis right now. Which brings us to the ultimate question, the one that ties all of this together. How do we continue to feed a growing population without bankrupting the very water accounts we depend on? Answering this might be one of the most important challenges we face in this century. Look, there's no single easy answer here. There's no magic technology that will fix this. This isn't just a problem for water scientists, or a problem for economists, or a problem for politicians. The only way forward is to connect all those dots. We have to combine our knowledge of how water systems work, how human beings respond to incentives, and the messy reality of politics. Only by weaving all those threads together can we hope to build solutions that don't just look good on paper, but that actually work on the ground to secure both our food and our water for the generations to come.